4.4 is on two parts of a triangle that we have not learned about, one called a median and the other called an altitude. Your job will be to know what happens when we intersect all three medians and what happens when we intersect all three altitudes of the three sides of a triangle. So the first thing that we should know is, what is a median? A median is a segment connecting a vertex and the midpoint on the opposite side. It would look something like this. I take a triangle and I need to go to the midpoint on the opposite side. Let's say this is the midpoint. I go from the vertex to a midpoint and these two pieces are congruent to each other. That's what a median is. A median is not necessarily perpendicular. A median does not necessarily cut that angle directly in half. It just goes from a vertex to a midpoint. And rarely will we ever give you a single median by itself. Most of the time we're going to give you medians with all three things crossing each other at the same time. If I have from the vertex to a midpoint and from the vertex to a midpoint and from the vertex to a midpoint, those three lines are called medians. All three medians are concurrent. That means that they will intersect at the same point. And they meet at a place called the centroid. This is the third word that you need to know. You have learned circumcenter. You've learned incenter. I hope you know how the circumcenter and the incenter are created. This is created in a different way. It's created by intersecting these medians. Now, the centroid has some very specific properties about them. These are the mathematical properties that it has, which I'll talk about in a second. But I also like to talk about its physical properties. This is a triangle that I drew on a piece of cardboard paper. Okay? And then what I did is I cut out the triangle, and then I measured with the ruler how long this side was. I found the midpoint, and I made a line from here to there. And then I did the same thing here. I found the midpoint of this side and found the dot and made a line from there to there, and so on. These are three medians. This particular centroid is right there. The physical properties that this has is that, let me find pencil, here we go, we'll use this pencil right here, is that if I get a pencil and I were to stick this pencil right underneath that centroid, if I can do this right, it's also known as the balancing point of this triangle. Well, it's really hard to do this on camera, but I am going to attempt to do it one more time. Let's try one more time. If not, I will just do it in person live with you guys. Woo! Ta-da! So now I'm going to show you guys live in the classroom what it looks like. Right there. It's the balancing point. That's exactly at the centroid, right there. And why does that work? Because the centroid is exactly 1/3 to 2/3 this direction, and 1/3 and 2/3 in that direction, and 1/3 and 2/3 in that direction. It's the exact balancing point. So a variety of our problems are going to come from this fact. I might give you the full length, and you have to find this piece and this piece. I might give you just this piece, and so on. Let me give you an example real quick. If I know that GE is 12, you should be able to figure out what GC is, and you should be able to figure out what CE is. If the full length is 12, this is the part that's 1/3 of the whole thing. So how long is GC? If you know how long it is, say it out loud. 4. I agree. And if how long is CE? CE, it would be how long? Say it out loud. 8. I agree. 1/3 and 2/3. 2/3 is twice as big as 1/3, so sometimes you can just double it if you know from the centroid to the midpoint is the 1/3 part, and the other one is 2/3. You can just double it. It's kind of nice. So that fact, we're going to do I have an example for you just like that. This is number 1 in your textbook. If you would like to write this in your textbook, you may. if YU is 3.6, I'm going to write that 3.6 right there. Find ZY and ZU. So I'm hoping you know that YU is 3.6. This is on the 2/3 part, which means that you should be able to figure out what YZ is by dividing it by 2. So that makes YZ how much? Say it out loud. 1.8 is what most of you said. That's correct. And now that you know that ZY is 1.8 or half of that, remember this is 2/3, this is 1/3, this is twice as big as that, so you divide it by 2, and now you can figure out what the length of the whole thing is. What is ZU? Say it out loud. I agree, that's what I got in my head too. So the first thing that we learned about were these things called medians. The medians intersect in a place called the centroid. Centroid divides it into 2/3 and 1/3 parts. The next big idea are these things called altitudes. An altitude is a perpendicular segment that goes through the vertex, and it's just on the line containing the opposite side. That's kind of different. So let me make sure you understand what an altitude is. If I had a regular triangle, this is what an altitude would look like. That perpendicular line. It goes through the vertex and is perpendicular to the line containing the opposite side. And I'm going to say this is the vertex through point A. But if I had a obtuse triangle, and this is point A now, the highest point to the line containing the opposite side. Sometimes you have to actually think about it like this, like, oh, this is the line containing the opposite side. What's perpendicular to that would be this. Sometimes your altitude can be outside of the triangle you're drawing. So that's why I have this altitude outside for an obtuse triangle, and I have it inside for a regular, a right or an acute triangle. That's what this shows. Now, what happens when I intersect all three altitudes? It produces the fourth thing that you need to know, called the orthocenter. The orthocenter is the last of the 4 concurrent lines of a triangle. We've talked about a circumcenter. We talked about an incenter. We talked about the centroid. The fourth one is the orthocenter. It's just a place where the 3 altitudes intersect. That's an orthocenter. That's an altitude. That's an altitude. That's an altitude. Sometimes the altitude's on the edge of the triangle, and sometimes your orthocenter is on the triangle. Sometimes your orthocenter is outside of the triangle. Now, the sad part about this is this is just the fourth one. It has no specific properties. The circumcenter is cool because you can make a circle going through the outsides. The incenter is cool because you can make a circle on the inside. The centroid is cool because it's the balancing point and has the 1/3 and 2/3. The orthocenter is kind of like, it's just an orthocenter. That's what it's called when they intersect. And there's no special properties about it. It's kind of like vanilla. It's good ice cream, but it's vanilla. Yes, sir.
The example you did with the obtuse triangle, how would you find the orthocenter of that?
You keep extending this line. You find the altitude of this one here. You find the altitude of, that was this side. We have this side. Now I need the altitude of this side, which would be here. And they would intersect out there. This is the same example right there. See how this is the altitude outside, and then the altitude of this side, and then if you contain the line there going out perpendicular, the orthocenter would be outside as well. Just plain vanilla. I have 2 more examples for you, and then we'll be done with your notes. This is number 9 in your textbook. Number 9 says, if BK is 15, what is KQ? And so the thing that you have to do sometimes when you're dealing with problems, especially like this, is they're going to try to confuse you based off of the picture. Like I see that this is an altitude because it's at a right angle to that side. B is this line here is an altitude. That's an altitude. From B to Q, since it's going from a vertex to a midpoint, this is a median. And then I can look and see I have another midpoint right here because these 2 pieces are congruent to each other. So this must be another median. When 2 medians intersect, this is called a centroid. If that's a centroid, even though it doesn't have that 3rd line going through there, there would be a 3rd line going through there if we wanted to figure out where it was. You don't have to have it though, because they're all concurrent. All 3 lines are going to intersect in the same spot. So if this is on the 2/3 part, and they want us to figure out how big this is, the 2/3 and the 1/3, all you have to do is cut it in half. Half of 15, you can either say 15 over 2, or you could say 7.5. That's what your answer would be. Last example. Oh, not last example. My last example is number 17. But I threw this in here in your notes. It's in your book, so you don't need to write it down. I think the hardest part for most of you, or for my students last year, is just knowing how the different things are created. What we'll do on your chapter test is we're going to delete these words and these arrows. And what you're going to have to do, and I'm going to mix all 4 of these triangles up, and you're going to have to know the names of those 4 different intersections. Your job will be to know when you have an altitude and an altitude and an altitude intersecting, it's called the orthocenter. When you have median and a median and a median, it's called a centroid. Where I have angle bisectors, angle bisectors, and angle bisectors, it creates something called the incenter. When I have a this one doesn't show a very good job, a perpendicular bisector. I wish this drawing had those marks in there. That way, then I would know it's the circumcenter for sure. That's a main idea, just so you know. Last example. Name the orthocenter of XYZ. They're going to try to confuse you on this one. I want you to look at it. If you think you know what the orthocenter is, I want you to discuss what you think it is with your partner sitting next to you. Go for it. I've heard a variety of different answers, so let me just kind of ask you all together. You're going to hear a bunch of answers. I want you all to say it at the same time so that way we can hear how many say the same letter and how many people say the different letter. Okay? Name the orthocenter of triangle XYZ. You all would say letter? Y. I heard a bunch of different answers there, but I heard one letter more than every other one else, and it was the correct one. Most of you people said Y. And you are correct if you said that. Let's figure out why. Orthocenter is the intersection of the altitude. So let's find the altitude here. This is perpendicular to that side. And that's of this side. If I go and I say, this is perpendicular to side xy, what is perpendicular to side yz? Where's the altitude of that? It's this line right here is the perpendicular to yz. And now let me go to this side as my bottom, and the highest point perpendicular is this one. So if I think about these lines intersecting, all three altitudes intersect at the point y. If you thought v, you're thinking centroid, by the way. Well, maybe centroid, that's a median. And then an altitude where the median and altitude intersect, we don't know where that is. That's actually not even a centroid, to be honest with you. So we'll stop your notes right there.